Welcome back to All This Math. This is Professor Parker. As you may see, I got my Huey P. Newton sweatshirt on, and I'm being intentional in terms of wearing this sweatshirt because today, while I record this video, this is February 17th, 2023, and February 17th is the birth date of the late Huey P. Newton, one of the co-founders of the Black Panther Party for Self-Defense. He was born February 17th, 1942. February 17th, 1942. As I stated, he co-founded the Black Panther Party in 1966, along with Bobby Seale. They went on to do a lot of positive work for the Black community that we need to get back to and start doing for ourselves today so that we can improve things for ourselves. But I definitely highly recommend you go check out Huey P. Newton, do some research on him, read some of the books that he wrote, such as To Die for the People, also his autobiography, Revolutionary Suicide. And there have been a lot of biographical accounts that have been written about the Black Panther Party. Some of them are better than others. So, you might have to mine through those to find out the ones that are more quality, but definitely familiarize yourself with the late brother Huey P. Newton, as well as the Black Panther Party for Self-Defense, if you're not as familiar. All right, now, today we're going to get into some geometry. We're doing a quick lesson on angle relationships. I got an example up here. Wait, hold up. Where should I stand at? I'm about to stand right here so you can see everything. All right, look. Yeah, angle relationships. All right. So what we have is we have a diagram right here with a line, and you know this is a line because it's got arrowheads on both ends. Lines extend in both directions onto infinity, right? Lines never stop. Line segments stop at specified points, but lines go on forever. All right, and we got two lines right here. What I should have did, what I neglected to do in this diagram is show that these two lines are parallel. So let me indicate that because I forgot to draw that. So in order to do that, this is the parallel symbol. Then you got the actual lines. You know what I'm saying? Like the double arrows mean that these lines are parallel. Now, what does parallel mean? Geometry got a whole bunch of vocabulary terms. Geometry is a language in and of itself, just like, the English language has a lot of vocabulary. You need to learn the vocabulary so you can speak the language, and also so you can understand the language when somebody else is speaking it to you. You got to learn the vocabulary. So just like you learn the vocabulary of typical English, you need to learn the vocabulary of all mathematics. Specifically, you need to learn the vocabulary of geometry. So parallel, what does it mean when lines are parallel? When lines are parallel, that means that, for one, they will never intersect each other. They're never going to intersect each other, right? All right, so this line and this line will never intersect each other, right? Meaning they'll never cross each other. Like this line and this line, they intersect each other right here at that point. This line and this line intersect each other right at that point, right? These two lines will never intersect each other, and also they are equidistant. Every corresponding point on this line and this line are equidistant from each other. So imagine if we were to identify a point on this line and also a corresponding point which is directly vertical beneath it on this line, and we say, okay, well, those 2 points are 6 inches apart. All right, this point and this point, 2 arbitrary points, right? Random points I picked, 6 inches apart. That means that every pair of corresponding points between these two lines will also be 6 inches apart, right? All the corresponding points are equidistant. So 2 things to remember for parallel lines. For one, you might just visualize and say, okay, they look like they're parallel, right? But the lines will never intersect each other, and all the corresponding points are equidistant. That means equal meaning equal distant means distance. They will have the same distance. All right, so let's talk about this diagram again. We got 2 parallel lines. We got another line. We call this a transversal. When a line cuts through 2 lines, we call it a transversal. Now, when that happens, angles are created. All these numbers represent different angles. This is angle number 1, angle number 2, angle number 3, angle number 4, angle number 5, angle number 6, angle number 7, and last but not least, we got angle number 8, right? So, and over here, this is what we're going to answer. Which are true? All right? So we got 4 statements. Statement A, statement B, statement C, statement D. All right? We're going to answer these questions, right? Well, they're not questions, but we're going to identify them as either true or false. All right? So let's read Statement A. Statement A says that angle 1 and angle 2 are vertical. Now, before we answer this, we need to know what vertical means in this context. Vertical don't mean, in this context, it don't mean up and down. That's not what it means, all right? We got to understand when we're doing math, we need to know that a certain term may mean one thing in a certain context. It may mean another thing in another context. Just like the English language. There are words in the English language that can be spelled the same and pronounced the same, but they mean different things in different scenarios. Math is the same exact way. It's no different. All right, so what does vertical mean? Vertical means angles that, for one, they share a vertex. They share a vertex. Now, what's a vertex? All right, a vertex is the point where two rays come together to form the angle. So if you think of, let's say, you can say your arm, right? This is a ray, your upper arm is a ray. Where they meet, right here, at your elbow, that's a vertex. That's a vertex. So when you think of angles, think, okay, this is a ray. Actually, it's a line segment, really, because your arm stopped right here, right? This is your line segment. This is another line segment. Where the two line segments meet, they form an angle. That point where the angle is formed is called a vertex. It's called a vertex. So the vertex is a point where an angle is formed, where two line segments meet, or where two rays meet, or where two lines meet, and they form an angle. All right, that's a vertex. So vertical angles share a vertex. You should write that in your notes. Vertical angles share a vertex. They share a vertex. What else? There's something else about vertical angles. Vertical angles are non-adjacent. What does adjacent mean? Adjacent means next to each other. Angle 1 and angle 2 are next to each other, so angle 1 and angle 2 are adjacent. And I just told you that vertical angles are not adjacent. They're not adjacent. So that means that angle 1 and angle 2 are not vertical angles. Angle 3 and angle 4, which are also adjacent, are not vertical angles. Angle 5 and angle 6 are not vertical angles. Angle 7 and angle 8 are not vertical angles, even though they share a vertex. They share a vertex, but they got to share a vertex in order to be a vertical angle. The other part is they can't be adjacent to each other. 1 and 3 are adjacent and they share a vertex, but because they're adjacent, they're not vertical angles. 2 and 4, not vertical angles. 5 and 7, not vertical angles. 6 and 8, not vertical angles, right? So statement A says angle 1 and angle 2 are vertical. We just established that they can't be vertical because they're adjacent. Remember, adjacent angles are not vertical angles. They can't be vertical. All right. Now, when I was in high school, check this out. When I was in high school, the way I learned vertical angles and the way I learned to remember them and to recognize them when I see them, either on a board or on a piece of paper or on a test or in a textbook, is this. I look at two lines, right? Either 1, 2, or I can say 1, 2. They could be lines, they could be rays, they could be segments, whatever. If angles are formed, the vertical angles are the angles that are not adjacent, but they're across from each other. They're across from each other. So this angle 1 and angle 4 are vertical angles, right? Angle 2 and angle 3 are vertical angles. Angle 6 and angle 7 are vertical angles. Angle 5 and angle 8 are vertical angles. These are vertical angles. These are examples of vertical angles. All right? So we know that angle 1 and angle 2 are not vertical. So let's do this. I'm going to put an F up here. Excuse me. Because that's false. That's false. Angle 1 and angle 2 are not vertical. So that means that's false. Angle 1 and angle 2 are adjacent, so they can't be vertical. All right. So basically, another thing, let me reiterate this point. If you see lines that form an X, see how this looks like an X, like Omowale, Malcolm X, the angles that are across from each other, right? Not next to each other, not adjacent, but across from each other are vertical angles. So 1 and 4 are vertical. 2 and 3 are vertical. 6 and 7 are vertical. 5 and 8 are vertical. All right. Now, let's go on to choice B. Choice B says angle 7 and angle 8 are complementary. Complementary, another vocabulary term that we have to learn. Complementary. Complementary in a geometric context means this. Do the two angles form a right angle? That's the definition of complementary angles. Complementary angles mean this. The two angles form a right angle or a 90-degree angle. So basically they form an angle that looks like this. A capital L. All right? It could be a right side facing capital L. It could be a left side facing capital L. But so this is only one angle though, right? So if it was a situation like this, that's angle 1, that's angle 2. So angle 1 and angle 2 put together make the big capital L, which is a 90-degree angle. So those two angles will be complementary. So look at angle 7 and angle 8. Here's angle 7 and angle 8. There's no symbol here, and actually no, these form a straight line. So when two angles form a straight line, when you put them together, those angles are considered to be supplementary. Supplementary. Supplementary, straight line, complementary, right angle. Complementary forms a right angle. Supplementary forms a straight line. Remember that and write that in your notes. All right, so this is false. That's false. B is false. Now, choice C. Angle 2 and angle 6 are corresponding. I should have put angles. Yeah, corresponding angles. Corresponding angles. Now, another vocabulary term. What are corresponding angles? Corresponding angles are like this. If you ever have a pair of parallel lines and you have a transversal that cuts through the parallel lines, you look at where your angles are. You look at the relationship the angle has with the lines that form the angle. So this angle 2 and angle 6, right? Angle 2 and angle 6 are corresponding angles. So let me say true, but let me tell you why. Because in relation to this line and this line, angle 2 is in the same position as angle 6 is in relation to this line and this line. So notice how angle 2 and angle 6 are both to the right of the transversal. They're both to the right of the transversal. And also angle 2 is above this parallel line and angle 6 is above this parallel line. So that means they're in what are called corresponding positions. They're in corresponding positions. They're both to the right of the transversal and they're both above their respective parallel line. Angle 2 is above this one. Angle 6 is above this one. What are some other corresponding angles in this diagram? Angle 4 and angle 8 are corresponding. They're both to the right of the transversal, and angle 4 is below this parallel line. Angle 8 is below this parallel line. So they're corresponding angles. What about angle 1 and angle 5? They're also corresponding because angle 1 and angle 5 are both to the left of the transversal, and they're both above this parallel line and above this parallel line. So they're corresponding. So think about what the word corresponding means. Similar to if somebody's sitting in a classroom, right? Somebody's sitting in the classroom, and let's say you're in a school building where it's like the school building is 5 stories high, right? And every floor in the school building looks the same, is set up the same, the architecture is the same, everything's the same, right? From floor number 1 to number 2 to number 3, number 4, number 5. So the classrooms are basically stacked right on top of each other, just on the different floors. So if you're a student and if the desks in the classroom are arranged in the same pattern in every one of those classrooms, then that means that the person that's on the 5th floor in a particular classroom, right, that's sitting in a desk near the door is corresponding to the person on the 4th floor in the classroom right below that one that's sitting in the desk right by the door. That is also corresponding to the person on the 3rd floor sitting in the classroom underneath of that one on the 4th floor, sitting in the desk right by the door, right? So those are corresponding spaces inside of a classroom. The same thing applies here with angles. You can have angles in corresponding positions. Like angle 3 and angle 7 are corresponding because they're both to the left of the transversal, and angle 3 is underneath of this parallel line. Angle 7 is underneath of that parallel line. So they're corresponding also. So C is true because 2 and 6 are corresponding. Like I said, 2 is above the parallel, 6 is above the parallel, and they're both to the right. All right, let's look at choice D. Choice D says angle 5 and angle 7 are supplementary. Now, again, We talked about supplementary earlier when I talked about 7 and 8. Supplementary means that the two angles come together to form a straight line. Supplementary means the two angles come together to form a straight line. They're supplements to each other. Supplementary, think when you see or hear the word supplementary, think those angles form a straight line. When you hear the word complementary or see the word complementary, those angles form a right angle, a 90-degree angle. Right angle, 90-degree angle. Complementary, supplementary, straight line. 7 and 8 are supplementary. 5 and 6 are supplementary. 3 and 4 are supplementary. 1 and 2 are supplementary. Because this angle with this angle makes a straight line. That's something that's called the angle addition postulate as well. Angle 3 and angle 4 put together make this straight line, right? Angle 5 and angle 6 put together make this straight line. Angle 7 and angle 8 make that straight line. Now, what about 5 and 7? 5 and 7, that angle and that angle, they also make a straight line when you put them together. Because look, this is what happens. In case you can't visualize it, this is what's actually happening. So this is angle 5, and this is angle 7. So altogether, you got two angles put together that come together and form a straight line. This angle combined with that. So you can it's almost like you imagine that this part isn't even here. When you combine this angle with this angle, you can almost imagine that this line isn't even here because this line is irrelevant. Once you put these two angles together, this line segment this part of this line that's sticking out is irrelevant, right? Same thing with angle 1 and angle 3, right? Angle 1 combined with angle 3, they form this straight line. So you can almost act like this part of this line isn't even here. Same thing with angle 2 and angle 4, forms a straight line. You can act like this line ain't here. 6 and 8 form a straight line. So all of those, whenever two angles, or it could be more than two angles, sometimes it could be 3 angles or 4 angles, but whenever angles come together and combine to form a straight line all together, you end up with a straight line. Those angles are supplementary. Those angles are supplementary. All right. So this is also true. So C and D were true. A and B were false. But the important thing is to know why, right? Know why they're false, know why they're true. Know your definitions. Geometry has a lot of definitions, just like algebra has a lot of definitions. But geometry has a lot of definitions. So you want to learn the definitions, even if you got to create flashcards and on index cards and just write the term on the front, write the definition on the back, write a little example on the back, maybe whatever. Whatever you got to do. Memorize the definitions. Know what a vertical angle is. Know what complementary angles are. Remember, they form a 90-degree angle when you put them together, right? Know what corresponding angles are. Know what supplementary angles are, right? Now, when we talk about corresponding angles, this example didn't cover that, but we usually also talk about alternate interior angles. We talk about alternate exterior angles that I'm going to discuss in another video on the channel. Make sure you subscribe to the channel. We also talk about same side interior angles, or some textbooks call those consecutive interior angles. All right. So alternate interior, alternate exterior, and consecutive interior, AKA same side interior angles. All right. So again, practice these types of problems where you have to identify the relationships between the angles, because the point of knowing how to do this is so you can solve problems that involve shapes and diagrams that look like this. Because you're going to have problems where you have to evaluate and find out the measurement of certain angles. And you might have an algebraic expression to represent angle 4 and angle 1. So then you might say, okay, well, first, what's the relationship between angle 1 and angle 4? I look at that and I say, okay, well, they share a vertex and they're non-adjacent. And I see this X that's formed. These angles are across from each other, not next to each other, but across from each other. That means they are vertical angles. You'll also find out that vertical angles are congruent because all of these different angle types have relationships. They have special relationships. I already told you about the complementary angles. They form a right angle. So if they form a right angle, that means they add up to 90. Their measurements add up to 90 because the right angle is 90 degrees. The supplementary angles, they form a straight line. And a straight line has a measurement of 180 degrees. This is all more information that you're going to have to memorize. All right. These are the fundamentals of geometry. So when you're doing the algebra, you can create an equation. And once you create the equation in geometry, you're not even really doing geometry no more for real. You back doing algebra 1 again. So that's why you got to be strong in algebra in order to do geometry and to excel at geometry. Because you got to have that strong foundation in algebra 1 so that you can excel in geometry. Because if you're strong at algebra 1, once you get to geometry, all you're going to really have to do is memorize the definitions, the theories, and then take the information in the theories, and then that's going to enable you to create equations, your own equations. See, here's the thing. A lot of algebra 1 is your teacher just giving you the equations and telling you to solve them. When you get to geometry, you got to understand the theories and how the different shapes are related to each other, the different angles are related to each other, the different sides of the polygons are related to each other, and then you create your own equations. So that's when you're taking a step up. You're at a higher level because now you have more independence. Now you got to create your own equations. It's not just your teacher here, boom, solve this equation. Now you got to take a step back and say, okay, well, let me create my own equation. You know what I'm saying? So definitely practice with these terms. Make sure you understand angle relationships. All right. Get some practice. Ask your teacher, ask your professor, whoever you need to, or just do an online search for problems dealing with angle relationships. All right. And I'll catch up with you on the next video. And don't forget, again, birthday shout out to the late Huey P. Newton. Peace.